Every time you open a website, your browser runs a fast chain of steps behind the scenes. It feels instant, but a lot happens in just a couple of seconds. We're going to open this page, https://northwind.app/catalog/headphones?sort equals popular. That one line tells the browser what to load and how to load it. The protocol says how to talk. The domain says which site. The route says which page. And the query says what option we want, like sorting by popular. Before the browser goes out to the internet, it tries the fastest path first. It checks caches, which are saved results from earlier visits. There are a few layers. First is the browser cache. It can store things like images, CSS files, JavaScript files, and sometimes even a previous page response. If the browser already has those files, it can reuse them instantly instead of downloading again. Next is the operating system cache. Your computer also keeps a small memory of recent network lookups, especially domain name results. This helps every app on your machine, not just the browser, avoid repeating the same lookup again and again. Then comes the DNS cache. DNS is the system that converts a website name into an IP address. A DNS cache is simply a saved record of that conversion, like northwind.app maps to a specific IP address. If that record is already cached, the browser can skip the DNS lookup step and connect immediately. So the purpose of checking caches is speed. If any cache has what we need, we skip network work and load faster. In this run, there is no useful cached result, so the browser continues. Next, it needs a real network address. Computers do not connect to a name like northwind.app. They connect to an IP address. DNS works like a directory. The browser asks DNS for the IP that matches the domain and gets back an address it can actually connect to. Now, there's one more modern shortcut. Many apps are served from nearby edge locations, so instead of talking to a faraway origin server, your request is routed to a closer node to reduce latency and speed things up. With the destination chosen, the browser opens a reliable connection. This starts with the TCP handshake. The browser and the server confirm they can talk and that messages can be delivered reliably. Once that handshake is complete, a stable channel is ready. But reliability is not enough. We also want privacy. Because this is HTTPS, the browser adds TLS on top of that connection. It verifies the server certificate, and then everything is encrypted while it travels. From this point on, the data moving across the network is protected in transit. Now the browser sends the actual request. It says, "I want the headphones catalog page sorted by popular." Along with that, it sends headers that describe what it can accept and how it wants the response. On the server side, that request moves through a processing pipeline. It gets routed to the right handler, the application runs its logic, it checks server-side cache for a quick answer. If needed, it queries the database to fetch the latest data. Then it assembles a response bundle, the structure, the styles, the scripts, and the assets needed to build the page. The response comes back, often in pieces. Usually the HTML arrives first, so the page skeleton can appear quickly. Then the CSS arrives and the layout snaps into place. Then JavaScript loads and the page becomes interactive. Images and other assets load in parallel, so the UI fills in progressively, instead of waiting for everything at once. Finally, the browser turns code into pixels. It builds the DOM from the HTML, calculates layout using CSS, and then paints the final result to the screen. That is the full journey from a URL to a finished page, happening in seconds. Once you know this chain, performance makes more sense. A slowdown can come from name lookup, connection setup, encryption, server work, downloads, or rendering. And the best improvements usually come from caching, serving from nearby, and keeping the page lightweight.